Hi everyone, we're going to graph the rational function, parent function, y equals 1 over x squared. And we're going to do a table of values here. If you plug in -2, you're going to get 1/4. -1 is going to be 1. 0 is going to be undefined because you can't divide by 0. On your calculator, it will show up as an error. And 1 and then 1/4. Okay, and then the domain's going to be all real numbers. So let's do the domain. Domain is all real numbers, but it can't be 0. Y can't be 0 either, because you can't get that from the rational. So you're going to have two asymptotes, a vertical and a horizontal. So I went ahead and graphed it here. Here is your graph. You can put in more values to help graph. Some of y'all might use a calculator. There's your vertical asymptote at x equals 0 and your horizontal asymptote at y equals 0. Actually, the range is actually wrong on this. The range is actually y is greater than 0 because all these numbers are positive, but it can't be 0. So sorry about that. Now, we did domain and range. There's no zeros because it doesn't intersect the y-axis, the x-axis. And there's no y-intercept either. Where is y positive? It's positive here in quadrant 1. So what's going on with that interval? When you're talking about the intervals, you're talking about what's going on with the x. Well, it's positive where x goes from 0 to infinity. So this goes all the way to bigger and bigger numbers. And it's positive here on this side. Y is also positive in quadrant 2 from negative infinity to 0. All right, and if you talk about end behavior, I'm just going to look at what's going on as x approaches infinity in this area. What's going on with the y? Well, the y, or your f of x, is getting closer and closer to 0. And if I look over here, as x, let's look over here, as x goes to negative infinity, what's going on with the y? The y, your f of x, also gets closer and closer to 0. This is your 0 here. Okay? Now, is it symmetric? Yes, it's symmetric to the y-axis. That means it's an even function. Okay. Is it 1-to-1? No, this is not 1-to-1. It doesn't pass the vertical line test because it hits two places here. That means we have to restrict the domain in order to do the inverse. So for the inverse, we're going to restrict this domain as x is greater than 0. We'd rather always work with quadrant 1. So we're going to restrict the domain for x is 0. And so I'm going to go ahead and do my table of values for x is greater than 0. So I'm going to use, I'll go ahead and use 0 where it's undefined. And do 1, 2, and 3. So 1 will go to 1, 2. It's going to be 1/4. And 3 would be 1/9. Now, which is just this part we've already know. This is it. So we're only dealing with this part. Now to do the inverse, what we're going to do is switch the x and the y. So we still have, well, undefined would go to 0. 1, 1/4 goes to 2, and 1/9 goes to 3. So if I graph this, and we probably need more values, but 1 will go to 1 again, 1/4, goes to 2. 1/9 goes to 3. All right. And then, so if I graph this, let's see. And basically what I'm getting is I'm just getting the same thing here. And you can't tell what's going on here, so I'm going to have to use some more values. So what I want to know is what's going on with 1/2. So if you divide 1 divided by 1/2 squared, that gives you 4. So I'm going to go ahead and switch the 4. Whoops, sorry. 4 goes to 1/2. So I go 4 goes down here. So basically, you get kind of the same thing like we did before on the other function. All right? Now we're going to have to do the transformations. Basically, the way you do this is the basic form is x minus h squared plus k. So I'm going to go ahead and graph these. The parent function, which is here. And now first do the horizontal. I'm going to go ahead and go to the right. So I'm going to graph the horizontal shift first. Let's shift to the right by 3. And we had a vertical asymptote at x equals 0. If we shift it to the right by 3, we're going to have a vertical asymptote at x equals 3. And then what I do from here is go down and just kind of graph it here. Whoops, it's a little crookedy. All right, so just graph it like this and get closer and closer. And I go down here and graph it. I should be up here, sorry. Graph up here. I was thinking of the other function. And this will keep going down and down and down. So this whole thing just got shifted over to the right by 3 units. That's a horizontal shift. And I think we can go down. I'm just going to go down quite a bit. I'm going to graph y equals x squared. I'm trying to not make a mess here like I did on the last one. So let's go down by 5. So if I take my original, which is the black function, and I'm going to go down by 5, that means for here the horizontal asymptote was y equals 0, so now it's going to be at y equals 5. So I'm going to go 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, right here. And draw my horizontal asymptote at y equals 5. And then all I'm going to do is just graph it based on my other graph. I'm just going to put my 1s in and just graph it based on that. And it keeps going up. I know it's a mess, but it'd probably be better if you did it on separate sheets. So this one was, the blue was the horizontal. And the green was your vertical shift down. Vertical shift down by 5. And this was a horizontal shift to the right by 3 units. Thank you and have a nice day. Bye-bye.